we go. Okay, so speaking to us tonight is the membership chair of WBBA and the MAPS coordinator for the Institute of Bird Populations, Dani Kaschube. And I don't know if Dani remembers this or not. I think she does, but Dani actually was the first person to ever train me on bird banding. And if you have ever participated in MAPS before, Dani might be the person that trained you as well, or trained the person that trained you. So we're getting some amazing knowledge tonight. So sit back, shut off your microphone, shut off your camera, and enjoy this wonderful presentation on Passerine molt. Take it away, Dani.
Thank you. So I have been looking at the names as people have been coming through the being admitted and the chats, and I know a lot of you, and I don't know a lot of the other ones of you. So hello to everyone I know, and I hope to meet everyone I don't know. I love to meet people at their banding stations and share the world of banding. I love this. So this is quite a large group, and I'm used to working with smaller groups. So Zach and Holly are going to help with the questions, but we're just going to kind of see what we can learn about molt. I know a lot of you know much more than what I'm going to present tonight, but a lot of you, this is going to be the earliest and the first experience you have with molt. So we're going to start at the beginning, and maybe we'll have some more advanced sessions later on. So I look forward to talking tonight. Okay, so just so you know which organizations are hosting us tonight, we have Audubon Rockies, and Zach is our controller tonight. He's letting people in and has done all the recordings. And we have Holly here with the Costa Rica Bird Observatories. And this webinar is sponsored by the Western Bird Banding Association. So we hope to have more of these types of webinars throughout the year, so on a variety of topics. So we hope you can join for those. And once again, I'm with the Institute for Bird Populations. Okay, so really I am starting at the beginning, and I want to talk about birds. Birds are found all over the world, on every continent and in every habitat imaginable. Some can fly, some cannot, some swim, some walk. But the thing that brings them all together are feathers. And that's what we're going to focus on today. So you should be pretty familiar with the species that we've got there. They're not too wild and crazy. And we all tend to be a little bit bird focused, especially at this time of year. But we will not be talking about this kind of bird today. Today, we are going to focus on passerines. So to narrow down what a passerine is, in case you don't know, passerines tend to be what we call the singing birds. Those are the birds that have the lovely songs that we hear, the ones that you see in the summertime. They often have bright colors, but they also have a unique feature in their leg that makes them part of the passerine group, and that as their elbows bend, their feet shut. So if their legs are straight, I don't know if you can see my little videos, their hands or fingers are loose, but as their legs shut, it closes their feet so that they don't have to actively hold on when they're perched on something. So that's a special passerine adaptation as well. So all of these birds, I'm going to go back here, all of these birds have feathers, and these feathers have to be taken care of by molt. How birds and different groups molt will depend a lot on their lifestyles. So today we're going to be focused on passerines, and know that all of these other species that are pictured here, they're going to do similar things at some points in time, but they're going to do very different things depending on their lifestyles. This is a really basic talk on molt. There are lots of other resources that you can learn more about molt on. This is, as you can see, the Identification Guide to North American Birds. This is a better picture of the front of it, but this is the reference I use most when I'm bird banding. But there's lots of information you can find for when you're out birding. The Sibley's one's a really nice introduction. If you are into molt and you want lots of detail, these two books that are higher up by Steve Howell and Jared and Wolf and Eric Johnson, these definitely dig deeper into the topic, and they're great references as well. So there are lots of references out there about molt if you want to learn more. So I welcome any, the research is great. Okay, so what is molt when we're talking about molt? It's really the change of feathers. That's all it is. Molt is the way that the birds keep their feathers looking healthy, because feathers are not live things. They're like your fingernails or your hair. The only way that you can keep them looking healthy is to change them out. Molt keeps bird feathers healthy, but it also allows the birds to change how they look, which they can use to help make themselves look more spiffy when it's time to breed or when they need to be more camouflaged. So this whole change of feathers can allow them to change how they look. Molt tends to happen for passerines on a regular schedule. So they don't just molt, decide on Tuesday it's time to molt. Things tend to happen in a specific time of year based on what biological processes are happening. Okay, and different species of birds or different groups of birds molt in different ways. So for example, our little passerines that we saw at the beginning, they are flying birds. They need to be able to fly at all times in order to feed, in order to get away from predators, in order to defend territories. So they have to molt in a very specific way that still allows them to fly. Whereas ducks and geese, for example, they can lose all the feathers that make them fly, their flight feathers, all at one time, because during the time when they have young, they can go out into the water to avoid predators. So they have that. They're also a bigger bird, so that most predators are deterred by their size. So depending on what a bird's lifestyle is, it will affect how they molt. So this is how feathers grow. I thought we'd start with something nice and technical. So when feathers molt, they start out in a follicle, just like a hair follicle, and they are encapsulated in a hard capsule. And this capsule has lots of blood vessels going to it. And you can see all the blood vessels down here at the bottom. And then as it grows, a center shaft develops. And then coming off the center shaft are these what are called barbs. And these barbs, you can't see it in this picture, are connected with little barbules. And that's what allows you to zip a feather. If you ever find a feather on the beach or on the ground and you re-zip it to make it look beautiful again, it's the barbs and the barbules that allow you to do that. So at the time when these are growing in, there's lots and lots of blood going to them. And if you happen to be in a spot where one breaks, they do make a bloody mess. Now, the bird stops bleeding quite quickly, but it is a messy, messy thing if you ever do break one of these feathers. And these happen both on the body and on the wing. All right, so this is what they look like in real life. So when you see this, so this is a cardinal, it's a female cardinal, and these little sticks, I know this is a technical term, but the sticks coming off here, these are the pin feathers or the blood feathers that we were talking about. So the feathers right now are encased in this, and this top will break off, just like, you know, the end of your shoelace breaks off, and you get that little tuft of feathers coming out. That's what this will look like. So this is its face. This is an American redstart, and this is the underside of a wing. And you can see there are 1, 2, 3, 4 feathers coming in. These 3, the little capsule has broken and these feathers are starting to emerge. But this one here, I don't know if you can see it, it only has a little tuft that is broken off. So these feathers out here are all the old feathers that haven't yet molted. And these feathers here are the ones that are in the process of molting. And down here, this little guy here, he's a little nestling. So someone's pulled him out of a nest for whatever reason, probably to maybe band him. But it's a great picture because you can see how the feathers have come in. In a bird, on a passerine especially, the entire bird is not covered in feathers. The feathers are in tracts. And then as the feathers break open, the skin spaces are covered up by those feathers that have opened. Okay. So the first feathers that passerines grow are a down feather, a natal down. I'm going to go back up to this guy. There's this passerine. Can you see the fuzz on his little rear end and then the fuzz on his hair, on his head? That's the natal down. So that natal down isn't very much good for anything except providing insulation when that bird is in the nest. It doesn't allow it to fly. It's okay at insulation, but really that nest and that little cup that it's in, because he's got that little cup and that little fluff and all of his buddies and his mom or dad sitting on top of him, that's how he stays warm. The first real feathers we call the juvenile feathers when we're talking about molt. Now these feathers, they're good. They will get the bird out of the nest. They'll allow the bird to fly. Oftentimes they'll allow it to keep going for an entire year, but they're not the greatest feathers ever produced. They tend to be a little bit shorter than feathers produced when the bird's an adult. They are skinnier. They're not as tough. They're not as dense. They're less colorful. They tend to be a little bit more pointed. So they're not the best in quality. And why? Because the nest is actually a very dangerous place and they have to grow those feathers very quickly. So we always think about nesting as, a nice place where you snuggle in and you get warm and it's very cozy. But really, when you're in the nest, you are just a bowl of food. So the little nest is a bowl and you are the lunch inside waiting to be eaten. It's really very dangerous. So birds have adapted to make that period when they're in the nest as short as possible. So when they're in there, you have your time when you're an egg, and then when they break out of the egg, then they have to grow all of their feathers, all of their bones, all of their muscles, all of their nerves. So everything has to be grown in a way so that when that bird leaves the nest, it's ready to go. Okay, so these first feathers that are grown, they're functional, but they're not awesome. Okay, also these feathers, these first set of feathers that come in, these juvenile feathers, it's the first feathers that the follicle has ever grown. So the follicle isn't really practiced. It grew a natal down feather, which was fuzz, and now it's got to produce a true feather that actually has function. And part of the reason they think that these aren't the best quality is that it's the first real feather the follicle has to produce. It's really important that we can be able to tell which feathers are juvenile feathers, because they're the feathers that allow us to age birds. And I'll explain that a little later on, but I did want to go through the fact that juvenile feathers are special, because it's a really important concept to remember when you're talking about molt. So when I try and teach molt or talk to molt about people, I talk about three things. So the first thing you have to understand is the theory, and that includes terminology. So we're going to talk about some terminology, which I know is just dry as all heck, but it will help you understand and put everything else into this grid of life and biology if you understand what the words are. If we just start talking about words without explaining them, then you get all lost, and that's no good. The second part is, once you understand the theory, is when you have a bird in hand, to be able to see the differences between the generations of feathers, feathers that are put in the nest, feathers that are put in as an adult, feathers that are put in especially to spiff you up for breeding. So being able to see that is the second part. And then once you know what you see and how the theory works, putting those two pieces together and applying that so you can figure out what point in the biology and the life cycle and the age of the bird is. Okay, so we're going to do all those things tonight. We're going to do it at a very basic level, but we're going to do it. Okay, so molt is very energetically costly. It takes energy both in the like biological process energy, and it takes energy in terms of the materials to grow the feathers. So the birds have to forage enough to get the materials, so they eat a lot of insects, and that has keratin that they can use then to transform into feathers. And then it really is energy, and the energy is both in how much work and energy it takes to make the feathers, and then how the bird is compromised when it is trying to molt. So when the bird is molting and it doesn't have those fluffy feathers anymore, it has those sticks, those pin feathers, it's not able to keep warm or cold like it would if it was fully feathered. So you don't want to be molting in the middle of winter, because then it's really hard to keep warm when you don't have a good insulation. And it's really hard sometimes. So that's one of the reasons why it takes a lot of energy. Also, when you have bodies molting, your body shape is not the smoothest and it's harder to fly. And lastly, your airfoil, or what keeps you in the air, is compromised when there's big holes because there's feathers missing. So think about an airplane. If you were in an airplane, you wouldn't want the middle chunk missing in order to take off. You want maybe a little hole if you had to have one, but you wouldn't want a big hole. So passerines, when they're molting, these are things that have to be considered. They're not consciously thinking about that, but evolution has thought about this for them. So costly for molt. And because it takes so much energy to molt, it takes place between other high energy cost events. So the birds tend not to molt and defend territories at the same time. They'll do one or the other. They don't produce young and molt at the same time, because both of those things are energetically costly. And then they don't tend to migrate during heavy molt. So all of these things, there might be some small amount of molt, but these processes tend to be a little bit separated by time. Okay, so today the terminology we're going to use something called a modified Humphrey-Parks system. Now, these guys were some pioneers in molt. In the late 50s, they coined some terms. So back when bird banding and birding started, people used very anthropomorphic or human-centric terms to talk about molt. They would say this is the nuptial plumage, or even just the breeding plumage or the wintering plumage, which is great when you're working with birds in the northern hemisphere. Okay, so these terms, these older terms used to fit. But when you started trying to apply these terms to birds in the tropics or even across taxa, it became difficult to use these very anthropomorphized terms. So Humphrey and Parks, they coined some terms so that we could talk about molt in birds across all the taxa, from penguins to ostriches to passerines to hawks to owls, so that we could use the same terms to talk about what's happening during molt, because all birds molt because all birds have feathers. So the first term we need to know tonight that they coined was the word basic. So they said that all birds have what's called a basic plumage. Some species only have a basic plumage. And the way you get from a plumage, that's what the bird looks like overall, is to do a pre-basic molt. So molt is called a pre to get into a plumage. So a pre-basic molt would get you into a basic plumage. We'll talk more about terminology, but a pre-formative molt will get you into formative plumage, et cetera, et cetera. And one thing that they said that was really important was that pre-basic molts, most or all feathers are replaced. Okay, so that's an important concept to remember as well. I'm not going to give you very many important concepts, but one of them is that juvenile feathers are special and that pre-basic molts are more where most or all feathers are replaced. Now, when Humphrey and Parks did their terminology back in the late 50s, they set out some rules and said, this is what we think this molt is, and this molt is, and this molt is. And through time, we have learned more about how the molts are and what the terminologies they're using and how to put things together. So we have modified that Humphrey Parks terminology. So that one book that I showed you up top at the very beginning, which was, I'm going to go back up here real quick. This black one that is my guide, it actually uses the original Humphrey Parks terminology, but it is being rewritten right now, so you guys can get your copy soon, probably the next year or so, I'm hoping. This uses an older terminology, and we have to do some translation if you're familiar with that book. But for today, we're going to use the modified Humphrey Parks and go from there. Okay, so two things: juvenile feathers are special and basic. Okay, so in general, what happens is we have a set of molts that happen in passerines that is pretty consistent through all passerines. So the first molt, where they get their first real feathers, is called their pre-juvenile molt. It can also be called their first pre-basic because all feathers come in at one time, or all feathers are replaced. This is the only time in the bird's life where all the feathers come in at one time. Okay, so we saw that little nestling above where he had all of his feathers coming in. They were all sticks at one time, only once in his life, because other than this, he has to be able to fly. The next molt that these birds will have is the pre-formative molt. So this is kind of what I think of as the teenager molt. Okay, these usually happens in the first fall. So the birds are a couple months old. Sometimes they're much younger, sometimes they're older, but we're going to say first fall-ish. So they're usually a month or two old. Okay, and only some feathers are replaced. Usually not the feathers that keep them flying, the ones on their wings. We're going to talk more about what those are in a bit, but just the ones on their body to help them be able to thermoregulate better and to make them a little bit more aerodynamic, but not usually the flight feathers. Something else that's you should know about passerine molt is that whatever rules I give you, there's almost always going to be an exception. So just be prepared for that. Okay, so this pre-formative molt, I think of it as a teenager molt. They're kind of awkward. They're in that stage where they're not really babies, but they're not really adults. They don't have much in terms of their energy budget, not much money in their pockets. So they have to be energetically thrifty, and they can't afford to molt everything. They can only afford to molt some feathers. So we'll see some pictures about these energetically thrifty birds in a little bit, but so that's our pre-formative molt. And then the next molt that these species have is the pre-basic molt. This is once again where most or all feathers are replaced, but they're replaced in a certain sequence, not all at one time. Okay, and then another molt that species regularly have is called a pre-alternate molt. Now, for North American passerines, this pre-alternate tends to be in the springtime just before breeding, but we don't want to call it a pre-breeding molt. Okay, that's once again anthropomorphizing it, and by calling it pre-breeding, it doesn't allow for some of the functions it has in other taxa. So in this case, we're going to call it the pre-alternate, and usually it's just like I said, for North American passerines, what we're working with here, it is what spiffs birds up for breeding. And if birds have migrated from a long distance, some of those feathers are also quite worn and they need to be replaced just for all the other functions that feathers have. There are other molts that lots of passerines may have, but these are the main ones, and these are the only ones we're going to mention tonight. Okay, so we're going to get some bird pictures in here instead of just some words, because I know the pictures are what makes it all interesting. So this is a song sparrow. Now, song sparrows are found across North America, and so a lot of people will have seen one. They're not necessarily backyard birds, but if you have any parks nearby, any kind of wetlands, and they're very ubiquitous. Song sparrows, you know, they're quite out there in the world. Okay, so when a song sparrow comes out of an egg, it's going to grow all of its feathers, and it's going to look like this. Okay, see how he's a little bit fluffy? The feathers, they don't have much structure to them, so they don't stick together as well. These are the poor quality feathers. Okay, and a couple months later, he's going to molt, and he's going to go into what's at this adult form. Now, song sparrows in different parts of the country can be darker than this. Some of them can be lighter. Some of them are almost pinky too. So they can have variation because this species is so widespread. It is, it can have variation between the different regions. Now, this bird looks like on the bird on the right. It's going to look like that right now, and then it's just going to continue. Every fall, it's going to change its feathers, and it's going to look like this again and again and again. So it's not really going to change much through time. The only time it's going to look a little different is when it's a little fluffy. Now, you see this nice dark spot down here? The juveniles tend not to be so dark in there. This guy, he's got no real streaking down here. This guy has heavy streaking, so they look a little different through time. Okay, the next one we're going to talk about is going to have an extra plumage. So this is a chipping sparrow. Okay, this guy, this is what he starts out like when he's comes out of the nest. It's going to be quite a streaky little guy. Okay, and then he's going to change into what's called the basic plumage. Okay, and then he's going to, just before he breeds, go into what's called the alternate plumage. Now, the guy in the middle and the guy on the right, they don't look very different from each other. But the guy on the right, if you can see on the top, he's got this nice, brilliant red head, whereas the guy in the middle does not have that. And then in the fall, he's going to go back to looking like this. So he's not changing very much from time to time. And I've been saying he, but this could be a she. And the song sparrow that we had before, it as well could be a she. We don't know on sparrows what these guys look like, how they're different. Okay, so in this case, we have three plumages. We have the juvenile plumage, we have the basic plumage, and we have the alternate plumage. And the way they transition between those plumages was through molt. Okay, and now things get a little bit more complicated. So I wanted you to see that there's a lot of variety. These are all passerines, but they can be very different in how they molt, but they're still, the underlying systems are the same. So on the far left here, we have this fluffy guy, and he is recently come out of the nest, and he's quite fluffy, like I said. He actually has some wing bars that you can see in the adult do not exist. Okay, so these juveniles often have characteristics that the adults don't have. One thing I want to mention is that when a bird comes out of the nest, they are the same size as an adult. Okay, so once a passerine fledges, he's not going to get any bigger. That's just the size he is. So some people often say, well, he was so little, it has to be a baby. It may not have been a baby. It may have been another species. What we're looking for when we want to call things juvenile is whether they're fluffy. Okay, so in this case, this tanager, there's differences between the males and the females. So when this hatchier bird, if it was a female, it would pretty much look like this female on the top here. And the female will have a pre-basic in order to get, so the preform, it goes from this juvenile, it goes through a preformative to look something similar to this. This is not a formative species, but it's going to look like this, and then it's going to do its pre-base, it's going to do a pre-alternate, and it'll look like this in the summer, and then it's going to do a pre-basic. And so the females in this species, they're pretty much always going to look very similar to this. There will be differences, but similar to this. Whereas the males, it gets a little bit more complicated. So this little juvie, he would go through a preformative, and he would turn into this green color. Then the first springtime, he would go into this red color. But if you can see, he's kind of got some dullness on his wings. He's got some lightness under here. So he's not a full brilliant red. Then in the its second fall of life, it will go back to being this yellowy green color, and then it will turn to this red color when it's time to breed. So then it's going to go through a pre-basic to go yellow, a pre-alternate to go red, a pre-basic to go yellow, et cetera, et cetera. And its life cycle will then cycle in this space right over here from there on in. The important thing to remember with birds is that as soon as they hit their first summer, so they have their summer when they're hatched, the following summer, those birds are able to breed. They may not look fully adult, like he has dull wings and a little bit of yellow, but he is fully adult and fully able to breed. Okay, so I want to do some geography of the wings, but Zach, have there been any questions about the things so far that I can answer?
So we do have a few questions, but nothing that's necessarily specific to what you have addressed so far. Questions that are related, but not direct to. So I think you're fine to keep going, and we'll address these maybe more towards the end.
Okay.
Oh wait,
great.
we just had one come in.
Okay.
So birds that molt between basic and alternate plumage in the spring and fall, both the males and females do this, not just the males?
Correct. Now, oftentimes the males will do a little bit more to really get a bit brighter, but usually when there is a pre-alternate, both sexes do it, and if there is a difference in the degree, the male will do more. There are occasions, like I said, there's always going to be a rule that's broken. There are occasions where only the male does it, but that's really rare. Usually it's the female doing less, but she usually does some.
All right, I think that's it for now.
Okay, so when I think about molt is very tied to the lifestyle of a bird, and how the feathers and what the feathers of the functions are affects how they're going to molt. So in order for us to talk about how they're going to molt, you guys have to know where certain feathers are. So this is a picture from the Identification Guide to North America, and it's an image drawn by Steve Howell, and then I've taken the edges and gone into PowerPoint so that we can see what the individual feathers are. But if you have an Identification Guide to North American Birds, it's the picture right at the beginning of the book. Usually there is a body attached, a picture of the body here. And when I put this together, I was like, well, as bird people, we tend to look a lot at wings and ignore the bodies. So I thought I'd at least reference where this body should be, even though it's not on this picture. It is an idiosyncrasy that we birders and banders have, is just to focus on the wings. So trying to be sensitive to people who don't understand that. So this is what a wing looks like. Okay, and the first thing we're going to talk about is the primaries. Now, the primaries are the largest feathers on a bird. Okay, they are what push the bird forward or push the bird upwards. In a passerine, there are usually 9 or 10 of them. In this case, there's 9. Yep, had to check my drawing. So there are 9 of them in this case. Birds that are considered, if you more evolutionarily advanced, think of your sparrows and your warblers, things like that. They tend to have 9 primaries, and those that are more that are closer to other species, to the root of the phenology, they tend to have 10 feathers. So things like the flycatchers have 10 feathers, chickadees have 10 feathers in the primaries. But the job of these feathers is to push the bird up and to push the bird forward. Now, if you think about the feather, that's a pretty important job. So it's not a set of feathers that you could lose all at one time. If you did, you wouldn't be able to fly. So because of that, okay, I'm going to show you actually on a real wing where these feathers are so that you guys can kind of think of what they look like in real life. You can't see the outermost primaries, which are the ones that are on the far right, but you can see most of them here. I'm trying to get my pointer here. Here we go. So our primaries go out from here. 6, 5, 4, 3, 2, 1. Right here is our primaries, where our primaries start. And you can, oops, gone back now. So you can see what these feathers look like. Now, they are still almost see-through. You can almost see through these, but they are still a stiff feather. And their job, like I said, is to get the bird off of the ground. Okay, so when they molt, like I said, they can't molt all at once, so the bird cannot fly. So they tend to molt one at a time in a sequence. So they start at the inside of the wing, and they molt one, they'll molt this first feather. And usually when this feather is about quarter of the grown, this feather will be pushed out and the next one will come in and the next one. So as you go along, you usually have 3 or 4 feathers molting at one time so that you have a little piece that's a wing. Now, the fewer resources available, the fewer feathers are molted at once. So if you are in there are some species that molt one primary at a time. They finish that one primary and they do the next primary, but those are usually tropical species where resources are short and they don't have a time limit where they have to migrate or get somewhere in a certain time. North American passerines usually have 3 or 4 feathers on the go at one time, so they can still fly. They're not migrating, so they can still have a small hole. They can still forage. They can still get away from predators. Okay, so then these are the largest feathers, like I said, on the bird, and they are some of the stiffest. The next set of feathers we're going to talk about is the secondaries. Now, the secondaries and the primaries embed on a different bone. Okay, so they are separated in the bone, and if you have a wing, the wing will bend between the primaries and the secondaries. So this break here, this is where the wing will bend. Now, the secondaries actually have 2 sets of functions. Their first 6 have one function, and the last 3 have a different function. So our primaries were good for pushing. Now, they'll also be involved in the glide, but that's not their primary function. They're a pusher feather. These 6 feathers here, this next set inward, our secondaries, are really important for the glide. So they are not as asymmetric as these feathers. I'm going to show you a picture right now. So these feathers out here, you see how it's very narrow in the front and wider in the back, so that as those feathers cut through the air, they don't wobble. Okay, and these secondaries right in here, see, they're a little less asymmetric. They are still asymmetric, but they tend to be flat on the bottom. Okay, so these feathers are really important for the glide. Okay, now, so those are our first 6 secondaries, and when they molt similarly to the primaries. They're very important for getting the bird off the ground, and so they can only molt one at a time. So usually what happens is you get primary 1 right here, and then you can molt, and you get a few in, and when you get to about 4 or 5, then you start on S1. Okay, and then you'll still similarly have some maybe primaries molting out here, and you'll have some of the middle secondaries growing, but you won't have all of them missing at one time. Now, I said that molt is really important for keeping feathers fresh. One of the things that's really, really harsh on feathers is sun. In fact, it does more damage to feathers than pretty much anything else. So if you just let a feather sit out in the sun, it will eventually degrade and fall apart to pieces. So if sun is really important to keeping the feathers that are most exposed to the sun will degrade and need to be replaced most often. Well, these guys here, 7, 8, and 9, when the wing is shut, they are the ones that protect the rest of the wing from the sun. Now, I don't think I actually have a picture of the feathers when the wing is shut, which is, oh, I do, actually, handily dandily. As you can see, these are our feathers, our innermost secondaries. These are also called the tertials, and this wing is shut on this side, and you can see when the wing is shut, these feathers sit on top, and they protect all the other feathers from that really damaging sun. So when a bird is sitting on a perch, those feathers cover up all of the rest and keep everything from getting damaged. Okay. Now, another thing that these tertials are really good for is for when you want to have something be showy and exciting. So if you want to have some color on you, these feathers that are always showing and always sitting on top, that would be a great spot to have it. As you can see too, these feathers, you see how dark they are here? This is another thing. Another way to make your feather last longer is to keep it nice and dark. So remember when I was talking about those young birds being thrifty or not? These feathers here are so important for keeping the bird healthy and keeping the rest of the feathers intact. They're often ones that are molted when you're a teenager in that pre-formative, because you can get extra color when you're trying to show off to the ladies, and it also protects the rest of your feathers. Now, these feathers, they don't molt in a sequence because they're not used for flying or for keeping the bird afloat on the air. They're used for protection. They can molt all at once. It's usually S8 that molts first, but they don't have a very rigid way of molting. Usually S8, but not necessarily. Okay, so then we're going to talk a little bit about the primary coverts that we have up here. Now, these primary coverts that sit here, they sit above the primaries, and a covert's job is to cover. So they are covering the insertion points of the primary. So when you've seen a feather has a nice wide base, and they often have like what the rachis, which is the shaft or the really skinny part that's sitting at the top, that is what inserts into the bone. And these feathers sit on top to keep those shafts covered. And if you think about the way that a wing works, those little shafts, if you had wind and you were pushing your feathers down, the wind would go in between all of the sticks, which would make it not very efficient. By covering them up with the primary coverts, you stop the air from coming through. Okay, so those feathers are very important. They're very strong and very stiff so that they don't get moved around when the wind is blowing through the feathers, when all that pressure of pushing the feathers forward is happening. And what happens when they molt is they tend to molt with their primaries. Okay, so when primary 1 molts, primary covert 1 molts. Now, these are all, like I said, these are all rules for which there are exceptions, but we won't talk about the exceptions right now. We'll start with the basic stuff. Okay, so those are these guys over here. These are our primary coverts, so you can see what they look like. These ones up here, these are not the primary coverts. We'll talk about those in a moment, but these ones here are primary coverts. Okay, the next ones that we have, these are our greater coverts. Above the secondary, there's several tracts. Remember those lines of feathers that we saw on the nestling? There's several of those tracts. So we have our greater coverts, our median coverts, and our lesser coverts. We're going to talk about the greater coverts. Now these guys, they do a similar thing, is that they cover up where these insertion points are for the secondaries and help keep the flow of air over the wing nice and laminar and nice and smooth so that flying is efficient as possible. Now, when they molt, there is a slight difference where the first one to molt tends to be this one, and they do move in a very, in a sequence from inner to outer, but they happen so quickly when they molt. It usually, when you look at them and you see them, they're almost always in molt all at the same time. You don't usually see just one molting in these guys. When you see a picture of the greater coverts molting, you see a whole line of feathers when they're all molting all together. Now, something to think about is, what is the function of these feathers? They're not stiff like those primary coverts. They tend to be a little bit fluffier. In fact, if you are a bird bander, you notice that these guys are the ones that always get messed up in the net. They're a fluffy feather. So their job is to keep the flow laminar, but they also are sitting out on the wing and they're very exposed, so they can be damaged by the sun. So oftentimes when we get those teenage birds doing their preformative and being thrifty, they're going to replace the ones that are sitting on top that are most damaged by the sun when they molt. They will not molt all of them, they'll just molt some of them. Now, when they're in a basic, pre-basic molt, they're going to molt them all, but in a preformative, they may molt only some. Also, because these ones are sitting on top, these ones are going to be where we have a lot of color. When you have wing bars, you get wing bars. The color sits at the tip, and by putting a line of color together, you get a wing bar. And similarly on these medians, if you have a tipping to them, you get a wing bar as well. So you can see the tipping to these will provide a wing bar when you're looking at the birds through your binoculars or through your scope or whatever. So the tipping provides some color right there. Okay. Some other feathers that are important on the birds, we have the alula. The alula is equivalent to your thumb. So when you figure out the anatomy of things, the primaries insert here, your secondaries insert here, and then you have your thumb here. Now this alula, his job is to control the turning. So in a bird that does a lot of turning and twisting and through the woods and a lot of maneuvering, they tend to have a large alula compared to their size. And there are 3 feathers here. There's a greater alula, a lesser alula, and the alula covert. And sometimes they're numbered A1, A2, and A3. There's more and more research being done and looking at the molt of these to use it for aging, but oftentimes when birds are being thrifty in that preformative, they'll molt just this one, but not these 2. So I don't know if I have a picture of that, but we might see it later. And then we have this little guy here. This is the carpal covert. He kind of sits all by himself. He actually is a feather all of his own little tract. And his job is to make sure that as the wing opens, there is something covering this space so that you don't have a break when the greater coverts open this way and the primary coverts open this way. He covers that little space. And in terms of bird banding and figuring out the age of things, This bird, this is such a handy little feather to use with American Goldfinch, whether it has a tip or not. So if you're not familiar with that trick with the American Goldfinch, start looking at your goldfinches. The younger birds, the second-year birds, tend to have a tip on here, and after second years, we'll talk more about the ages later, tend not to. Okay, on this guy, I don't think we can, this is our carpal covert right here, and here's our Alula feathers over here. Okay, and then we have some lesser and medians. These tend to be more like body feathers. They tend to be provide a lot of color, wing bars, but their molt patterns are not as rigid. They tend to molt from the body outwards, but the pattern isn't as rigid. There is definitely a lot of variation in there. Okay, all right, so life cycle of a bird. So when we talk about how old a bird is, we, through time, have tended to put things on a human calendar, which once again works really great when you're talking about birds in the northern hemisphere. We can say the breeding season happens nicely in the middle of the summer, and we tend to focus, and then we have assigned the birds based on the calendar year, their age. We're trying to step away from that, but it's important to know how the different systems work together. So the year, the calendar year in which a bird hatches is called its hatch year. They were pretty basic when they used their terminology here. So when the bird is in the egg, and then it fledges, then when it becomes a nestling, okay, and then it fledges, okay, and it will get its first set of feathers. Now those feathers, they're not the greatest set of feathers. Remember, we talked about that because they had to grow all at once. This is its juvenile plumage. It's also its first basic plumage, okay, not great quality. And then a couple months in, it's going to have a molt where it's going to be thrifty. It's going to use its energetic resources wisely and molt some, but not necessarily all of the feathers. Now, depending on what species it is, how thrifty they have to be is really variable. So there's some species that molt just the body, like this bird could be a catbird or a wood thrush. They would tend to do a pattern like this. Something that's like a bush tit would molt everything. So they're not as thrifty. They have a different energetic concept for how they molt during this molt. So there's a huge variation here, but if a species is going to be thrifty in its molt, it's going to be right here. Now, if it's going to migrate, it would migrate during September to December time area, but there are lots of species that don't migrate. I'm sure you guys can think of some species that stay all year round. So things like chickadees. My mind always goes blank when it's time to things like this. Nuthatches, cardinals, woodpeckers, they don't migrate. So, but if you do have a species that migrates, it's going to do it now. Now, my calendar's a little funny because my January 1st should be down here, but it's not. So one thing that birds have that they share in this system is that they all have a birthday when we flip the calendar. So a bird that is a hatch year bird on December 31st will become an after hatch year, or more specifically, a second year bird as soon as you flip the calendar. Nothing happened biologically to the bird. We just, as humans, flipped the calendar and we made this bird a second year bird. Okay, so notice that this bird here, when he's all red, he's in what's called his juvenile plumage. He went through a pre-formative molt and got some new feathers. And because he went through a pre-formative molt, he went into his formative plumage. Okay, so he changed some feathers, but not all. And so he's in a new plumage. And down here, when he's a second year bird, he's still in formative plumage. The only thing that has happened is that we flipped the calendar to make him a new age. Nothing biologically, which is why we're tending to move away from this system, because it's not biologically relevant to this bird. And if we're talking about birds that molt in the that breed and molt in the tropics, we can't assign these calendar years to them. It just doesn't work. So after that, this bird is only a year old, but it is old enough to breed and produce young. It not necessarily mean that it will, but it is biologically capable of doing that. The next thing that happens is that in that following fall, possibly the winter, so this is a little bit variable by timing depending on the species, rigid for species, but variable by species, between species, it's going to do a pre-basic molt. And I don't know if you remember, I said in a pre-basic molt, most or all feathers are going to molt. And so that's when this would happen, is that it gets a whole new set of feathers and changes the quality of its feathers. It gets all of these red feathers that were very poor quality that came in the nest. They will be very worn out at this point in time. So they'll all be replaced, and this bird has a new set of clothing. Okay, it's going to go through the same pattern it did last year. If it's going to migrate, it's going to migrate. We're going to flip the calendar and we're going to make it a little bit older. So now it's after its second year. So it's an after second year bird. That's what that ASY stands for. And it's still after its hatch year. So we can be less specific and call it an after hatch year bird. And it'll continue to spend its time in the tropics if it migrated, and then it'll migrate back. And it will breed again, and it will follow this pattern. Now, this species here that I've shown does not have a pre-alternate, but if it did have a pre-alternate, it would be right in this time here, just before it breeds for Passerines in the Northern Hemisphere. Okay, so this is the life cycle of a bird. I'm going quite quickly because I'm running out of time-ish, but I wanted to show you some pictures. So, what we've created at the Institute for Bird Population is some similar things. We've gone through and we've created the molt strategy using just the wings, because I said we're a little wing fixated, and it's true. So this is the same idea that I just showed you on that other picture with only looking at the wings. So this is the bird in juvenile plumage. It would go through a preformative molt. It would replace some, but not all feathers. This is a gray catbird, by the way. And it would retain that. It would turn in, the calendar will change, so it will become a second year bird. It still will be a bird in formative plumage. It will retain that through the breeding season. It will change that through its pre-basic and go into its what's called its definitive basic or its adult basic plumage. And it will retain that, but it'll change it every fall just to refresh it. Okay, so some actual real birds so that you guys don't get bored with all of the theory. So we've done some terminology. We've worked on our theory. Now we're gonna put it into practice with some birds. So like I said, we are wing fixated. We have this problem. So I have put the birds on the picture as well, so that if you guys aren't sure what each of these species look like, you have some sort of reference to them. So this is my favorite bird to band. I think they're beautiful, for one thing. They fit in your hand so nicely. They're not real fighters, so you can hold on to them nicely. They have beautiful molt patterns. So this is my favorite bird to band. It really and truly is. So I hope you love them too. And they make cool sounds. I mean, that's too cool too. Okay, so I am showing you a bird in its formative plumage. So just as a reference, this person's thumb is where the body is. I know you can't see it, but you can kind of see the tail sticking out from the bottom here. So the bird's body is on the right side of the screen in this case. So this bird came out of the nest, and then it did its preformative molt in the fall. This is a springtime bird, so it did a molt in the fall to create this look. What it molted, okay, can you see how gray these are here compared to the brownish color of these ones? These brownish ones, they came in during the period in the nest when it was growing all of its feathers. They just aren't the best quality, and through time they have faded to this brown color. Then it replaced these two tertials, which are part of our secondaries, during its preformative. Now this bird, the species does not have a pre-alternate, so I know it did not come in the pre-alternate. I know it came in the preformative. Okay, and then you can see throughout here, these feathers, these greater coverts, were also replaced, and these two up here were not. So when we have two sets of feathers sitting next to each other, this is called a molt limit. These ones molted and these ones did not. So these are juvenile feathers. They came in that pre-juvenile molt. These are our formative feathers. They came in during our pre-formative molt, and there's a limit here. Okay, so knowing that, I'm going to go back up to my life cycle. We have a bird, and it's at this time of year. Okay, the springtime time of year. We have a bird that has two kinds of feathers. Okay, this guy, he all has the same. This guy has two kinds, and this guy has all the same fancy feathers. This guy has a mix of fancy and not fancy feathers. I know this bird is a second year bird. Okay, did that make sense? This is what we do as bird banders. Now, why is this important? Because we like to know how many adults are coming back year to year when we band. We need to know how many young are producing, so we can see the quality of the habitat there. But also, we like to know when second year birds show up on the scene. It's considered a truth when you think about habitats, that younger birds go into poorer quality habitats. So one second-year bird doesn't say anything about the quality of the habitat. But if you have only second-year birds of a particular species, for whatever reason, that is showing that that habitat is not a good habitat for your species, which is important when we're trying to manage habitats and manage areas. So if there's something where you have a lot of older birds, that tends to say that habitat is a better quality. Lots of second years, more than normal, that tends to say that this is a poor quality. So this is one of the reasons why we care so much about this. Okay, so I'm going to move on to this next one. This is a rose-breasted grosbeak. And this is from Mexico. This is a great bird because you can see that this bird has gone through its molt. Okay, so now in this bird, we have these great brown feathers. And if there was just there's just too many of you to do a feedback, I would love to ask you guys what you think they are. You feel free in the chat room to say, but these are juvenile feathers here. These here are formative feathers. You see how they're nice and dark compared to these juvenile feathers? I mean, that's nice and obvious. And then can you see that there's some brighter feathers here? These are pre-alternate feathers. These ones are ones that came in more recently. And there's more white on them. And they are just a little bit more vivid black. So I know that this bird is a second-year bird, and it's in alternate plumage. So we've been talking about plumages and stuff. Okay, so this is a wood thrush. And this, like I said, we're a little bit wing fixated. So we tend to look at a lot of specimens that are wings, and this is just the wing of the wood thrush. If you were interested in where the bird was, it would be over here on the right side. Now, this is a little bit more subtle than the ones that we've seen before. We can't really tell what's happening here in the primaries and secondaries. We think they're juvenile, but if you can look right here, can you guys see in the greater coverts? See these ones that are spotted? This is just like the robins you guys have in your yard. Remember those baby birds that are all spotted? These are the baby spots. These are the only ones, the body feathers of are missing, okay? But these are the only those spotted feathers that are are remaining. So when the bird was a baby, it had these spots all over, and it replaced these inner greater coverts. So right now we have a molt limit between here and here. And looking at the time of year, which is October, we know that this is a hatch-year bird. If this bird had made it through whatever incident caused its problem, looks as it hit a TV tower. If it had made it one more to the flipping of the calendar year, it would have been a second-year bird with this pattern, but it didn't make it that far. It only made it as far as its preformative. I think I'm going to do a couple more of these, and then I'm going to stop. I just wanted you guys to see a few more species. So this is a bird. This is a fully adult bird going through its definitive pre-basic. So remember how we talked, those young birds tend not to do their flight feathers? Well, we can see here that this bird is molting its wing. So this bird is not a young bird. This bird is an adult bird. Okay, and you can see that there's some pretty poor quality birds here. Feathers here. But we're not sure if these are truly juvenile feathers. I think they are, but I'm not sure. Or if they're just basic feathers from the previous year. But they look pretty brown. I would think that they were juvenile feathers. Okay, so this is a black and white warbler here. Okay, so now I'm getting a little trickier. So this one's a little less obvious. Okay, this is a YellowRumped Warbler, and it's in the summertime. And this guy's cool because he has 3 types of feathers. And so that means he's gone through at least 3 molts. So he got these juvenile feathers, which are nice and brown compared to these ones. So these are juvenile primary coverts and juvenile primaries. He got some new feathers during his preformative. He actually replaced all of these feathers during his preformative. And then to spiff it up for the summer, he got some of these inner greater coverts. And I say he, but it's a she, to look better for breeding. Okay, so this is a second-year bird in alternate plumage. Okay, and then I'm going to show, I think this is where I'm going to end with this last one. This is a Kentucky Warbler. I do have more, but I'm going to stop after this one. So this is a Kentucky Warbler, and so I wanted to show you a little bit more subtle ones so that you can see the difference. So the guy on the right here, do you see how it's got some greenish tinge to these feathers? Whereas these feathers here, they don't have that greenish tinge. They're a browner tinge. Okay. Also, you can see this A1, he's nice and molted, but these 2 haven't. Whereas on this one, this green follows all the way down. This is really hard if you're colorblind, by the way, I apologize. So if you are colorblind, you need to use other things like these tend to be a little bit more of a a sheen to them. These ones tend to be a little bit more dull and ratty looking. So that's one clue you have to use when you're if you are colorblind, especially on these green guys. That makes it very difficult. So right here we have a second year bird, and this bird here is an after second year bird. So this guy in that picture that I showed you at the beginning, this has both red and green feathers, juvenile and formative feathers, whereas these ones are all basic feathers here. Okay, I think I'm going to stop here because I can talk on molt for days and days, but you might have some questions at this point that we can answer.
Okay, I have got a list of questions already, and I'm sure there will be more pumping into the chat box as we go. So let me get some of these questions for you. Give me a moment here, pulling them up.
Okay. I'm going to move off some birds here, and I'm just going to remind everybody, in case people do start coming out, that this is from the Western Bird Banding Association. If you want more information about that, westernbirdbanding.org. And I work for the Institute for Bird Populations. If you're interested in more training or bird banding, birdpop.org. And Zach is, who's hosting this, is with Audubon Rockies. So we appreciate Audubon Rockies' contribution to this, and you go to Rockies Audubon. I'm going to put a plug in for donations. We're always all nonprofits, and we're always looking for support, and Giving Tuesday's coming up. So if you want to donate, that's awesome. And if, like I said, there's lots more information on these websites, and we'd love to have you visit or become a member of any of these organizations. I think they're all great organizations, and you know, we'd love new members and new people who are interested in birds. Okay, go for it, Zach.
Okay, first question. Do nestlings of cavity nesting species have as poor quality of feathers as open cup nestlings? Is there a difference in predation susceptibility between the two and other nests?
Well, now you have gone all hard question on me. So I don't know if there's any studies been done, but I'm thinking of chickadees versus your average warbler. Chickadees are cavity nesters and woodpeckers are cavity nesters, whereas it's an open cup nester like a robin and things like that. I wouldn't say that there's probably a difference in the two groups, but I don't know for sure. So there might be research question in there. More study is needed. All of you who have used Pile understand that statement. So I don't know if there's a difference in there. I would think that there's probably a difference in the migration strategy. So your cavity nesters like chickadees and woodpeckers tend not to migrate. That's not completely true, but that's the generality. And so something that has to migrate a long ways would need a better quality feather coming out of the nest than something that is is a resident or a short migrant. This would where I would think that the difference would be there.
Okay, next question. And Holly answered this a little bit in the chat, but I think there's something specific here that they were searching for. I've seen birds, usually juveniles, with most of their feathers stuck in the sheaths. What might cause this underdevelopment? Okay,
so it's not that they're stuck in the sheaths, it's just that they haven't grown fully enough to break out. So they're in mid-development. So those feathers are just coming in. So when you get a nestling, especially like at the beginning, that I'm going to go back up right at the beginning, we had that nestling picture where they were all in sheath. It's just that it hasn't, oh, I've lost it now. It's just that they haven't had time yet to break out. So give it another week and those feathers will have all broken out and you'll have a nice fluffy bird. Now, there are some birds, and this cardinal reminds me of that picture, where you get cardinals and blue jays. Sometimes they just have no feathers. I'm not sure what causes that. So I don't know if that's what you're meaning, but if it's just a bunch of feathers that haven't broken out, it's just time hasn't grown them enough for them to break open yet.
Have you ever seen a stunted feather?
Not one that, I don't know. The thing is that when I see birds, it's a snapshot in time. So once I let it go, I don't know what happens to the feathers. But it tends that feathers do grow. And I've seen weird things with feathers. I've seen feathers that didn't grow in properly. Sometimes they have lines on them. I don't know if you can see even this picture, you can see there's lines on them where a feather, there was some sort of nutritional deficiency in there. I've seen feathers with breaks in them. I've seen feathers that are extraordinarily long. So I've seen lots of strange things, but I don't know about the stunted because usually when I see things, it's just a snapshot in time and I don't know where things go from there.
Okay, next question. Does the energy cost of molt affect the bird physiologically? I get that they could be more susceptible to predation, but does it have side effects that could affect their day-to-day health?
I don't know the answer to that question. I don't know if they'd be more susceptible to disease at that point in time. It is part of the biology of the birds, so I don't know if there have been other compensations in terms of hormones that would protect them from that sort of thing. That's a really hard question. I just don't know the answer to. Zach or Holly, do you have any answer to that one?
I don't know of any studies on that that could provide me with an answer. Holly, do you have anything?
No, I don't think I can't think of anything either. I was thinking about that question as well, but it's definitely food for thought.
My favorite answer to questions that I don't know the answer to is there's more studies needed, and that sounds like a great graduate project.
Okay, next question. For a non-migratory species that does not have a distinct, basic, and alternate plumage, are there chances that the species / female would not molt twice in a year?
So if it doesn't have an alternate plumage, it is only molting once a year. So things like chickadees, they only molt once a year. Those song sparrows that I showed you at the beginning here, these guys here, they only molt once a year. If you have only a basic plumage, then you only molt once a year. And it's really, the longer you molt, the more likely you are to have a alternate plumage as well as a basic. The closer you stay to home to winter, the less likely you are to have an alternate plumage. Once again, there are rule breakers everywhere, but that's the general idea.
Okay, so back, I think when you were talking about feather shape, maybe someone asked the question of what is the purpose of emargination?
Well, as a bird bander, I think emargination is really handy when you're trying to tell species apart. But I don't know that's a very good question, the purpose of it. Because oftentimes some feathers on a bird are marginated and some are not. You want to have, let's see if I have a picture, go back here with this bird. You do want to have definitely the leading edge being thinner. Okay, I'm going to step back. Emargination is when this part of this leading edge of the feather is somewhat thick and it gets even thinner. These feathers here are not emarginated. Okay, so everyone's clear. The purpose of emargination, I don't know. Once again, Zach or Holly, I'm going to punt, see if you guys have answers. Nope. Okay, well, like I said, graduate projects lining up here.
Okay, next question, and this is just a clarification. When you were speaking about the carpal covert, specifically with the American goldfinch, and the helpful little tip that's not in pile, is the carpal covert tip, were you referring to color or shape?
It is a color, and it's a buffy tip. So this is not a goldfinch. This is a bunting, by the way. This is an indigo bunting. In case you're wondering what the heck this is with no head, it does have a head. I was going to mention that, you just can't see it. So the tipping here, this color here, that's what the American goldfinch has. It doesn't have this side bit, but on the carpal covert, it has tipping that looks very similar to this. Maybe a little bit lighter, but very similar to this color.
Okay, next question, and we've got quite a few more here. So anyone who wants to stick around for these, we'll try to get through as many of them as we can within our time allotment here. We've got a lot on Facebook as well that I will do towards the end. Is there a list of common bird species in different regions and the types of molts each species utilizes?
There is not a list. I'm actually going to step back from my steps here and pull this. This book, the Identification Guide to North American Birds, this is the explanation of the birds and what each of them does in terms of the molt. In every section, there's this listed by species. There's a molt section, which you cannot see as I pointed here, but there's a molt section that usually has an information line or two and then a paragraph about the molt. It will tell you what each of the species does, and in terms of molt, what times of molt, which feathers are molted, what the species look like. So this is the book for Passerines. This is part one. Part two involves other species like gulls and hawks and owls. Oh, are owls in here? I think owls are in the other book. Anyways, so these two books, they have the information that you need to answer that question.
And also, quick plug: Birds of the World, the online resource from Cornell Lab of Ornithology, in partnership with a lot of other groups as well, has a lot of that information on molts for almost every species in the world. So a lot of great information there as well.
Perfect.
Okay, this one came from Facebook. Why is the term hatchling not used to refer to unfeathered babies? And then they commented that it can be confusing to the public who find baby birds who aren't used to the hatchling versus nestling.
I think you can use that term hatchling. It's not outlawed. It's just when we talk about terminology, we are very specific in how we speak, so that we are clear about what we're talking about. And hatchling, I guess you could consider a hatchling to be something that's in the nest, that's something that's fledged, that's something of the same year. So I think the term problem with hatchling is that it's more broad of a term. And when we're talking, we are speaking about things that are in the nest, or things that have left the nest as a fledgling, or things that are in a specific plumage. So I don't think there's anything wrong with the term hatchling. I think it's just more broad, and it's not the term that's commonly used when we're being very specific.
Wonderful. Okay, next one. And I don't know if you had any photos that exhibited this well, but maybe just talk a little bit on stress bars versus fault bars versus growth bars.
Okay, so I'm going to see if I do have anything I can pull through here. Though I don't appear to, okay, there, I was going to say I wasn't able to control my own computer here. Let's see if I've got something here. I think you'd be more surprised at how often, okay, so here. I don't, and these feathers here, Zach and Holly, can you see the lines on there? If you can't see it, then I don't know what I'm doing. Okay, you can see them. Yep. Okay, so these feathers here, when they came in, do you see the lines that's on them? They look very faintly like zebra stripe. The more of these you look at, the easier it is to see them. So I'm hoping that these are fairly obvious. So if we look at the feathers here that have the tipping, the feather is flat. There's no lines. Whereas we look on these feathers that have come in, the ones that were replaced, they have these lines. The lines are not actually part of the plumage. If you took 6 other wood thrushes, they may or may not have these faint lines. These are called growth bars. And as a feather grows, if it has full nutrients and full hormones and full everything that it needs to grow the feather, and it's supposed to come in flat, it will come in as a flat color. However, if there's some sort of nutritional or hormonal something that's missing in that, you will tend to get barring, called these growth bars, and or stress bars, that show the differences where there's nutrition and not. And it tends to be a nocturnal diurnal pattern. So in this case, the darker sections is when the bird was eating and there was proper hormones and everything, all the nutritional requirements were being met. But then at night, when it stopped feeding, and then the nutrients that it didn't have enough to keep that whole growth process going, there was something missing. And at night is when it wasn't actually putting nutrients in, you get this barring. So these are stress bars or growth bars. And they're actually really, really common, like I said, and the more you look for them, the more you will see them. They don't indicate a particular age of bird. Any feather at any time of year where there's some sort of stressor when it's growing can have those bars. A fault bar is something where it's extreme, where the nutritional deficiency is really extreme, and you actually don't have feather, the barbs and the barbules are not deposited, and you just get the shaft or the rachis. So you get, I don't even know how to explain it. You get like a full feather, and then there's a line of missing material here, and then the feather continues. So whatever happened in here, there could have been a storm, there could have been something that happened that was extreme. And if you do get fault bars, it's at that point that the feathers often break. So we will get a bird where it's missing the tips of all of its feathers, and it's oftentimes where it had a fault bar, and then through the stresses of migrating and defending territory and all the things that, and just general life that the birds have, that part of the feather may have broken off.
Wonderful. Okay, real quick on the catbird, the actual photo of the catbird, would you go over the, someone just asked what the WRP on that catbird would be.
Okay, so there's
you don't have to go deep into WRP because we're having a lot of clamoring for a WRP webinar. So
okay, all right. So WRP is a system of aging that's based on the biology of the bird rather than the calendar that we were talking about. And it talks about the plumages of the rather than the actual calendar age. So in this case, I'm going to go back up again. And actually that picture I showed you of the diagram, it has the WRP codes on it. So you can go back and forth to that if you'd like. So this bird, it has limits and it has both juvenile and formative feathers in it. I'm actually going to go back up to here because this will be just easier to explain. So WRP is a system based, and it's Wolf Rider Pyle, the guys who created the system. It's WRP for their last names. It doesn't have a biological meaning. It's a naming meaning. Okay, so they have said Humphrey and Parks talked about the basic plumage, and that is what starts every cycle. So in this case, it had a pre-basic molt, and it's going into its basic plumage. So this is the start of a first cycle. It's doing a second pre-basic molt. So this is its second cycle, and this is its third cycle, and it continues on cycles like that. So for the WRP system, you need to know what cycle your bird is in. We decided our bird in that catbird case was in the plumage, in its formative plumage. Formative plumage birds only belong in the first cycle. So we would say it's an F for first cycle. And then it's not molting, so it's in its middle of its cycle, so you would say C, and it's in its formative plumage. So the bird that we were looking at, its WRP code is FCF for first cycle formative. Okay, I know that just went, people are saying, what words are she saying? But hopefully that answered that question pretty quickly.
And we can offer a future webinar kind of more focused on the WRP stuff, because that's probably a whole hour webinar in and of itself. So,
but we can make it an hour.
Jared, if you're listening, wink, wink.
Yeah.
Okay, so next question, and this one, I wanted to add it to the queue because it just, you've mostly been looking at wings, but their question was, are rectrices not important in molt study?
Yes, they are. And I just didn't have very many pictures of rectrices, and cool stuff, lots of stuff happens on wings. So rectrices, the birds, when we were talking about whether or not they're being thrifty or not, yes, they, birds, if they're being, okay, I'm gonna go back up. I have to get my thoughts in order here. So tails can be molted. Tails are not embedded in bone. For passerines, they're embedded in flesh. In woodpeckers, they're embedded in bone, but in passerines, they're embedded in flesh. So tails come out quite easily. And birds will often replace the center feathers of the tail in a preformative molt, because those are the feathers that are damaged most often. So a bird can molt no feathers in its preformative, just the center feathers in its preformative, its whole tail in its preformative, because they tend to get ratty from being drug around or being out in the sun. So tails have a less predictive pattern when you're talking about molt. And sometimes when you band, they just come out, happens. But in terms of the shape, that's what I think the question is. So these feathers that come in the nest, they tend to be narrow and pointed. And the ones that come out over here, or even in the preformative, if they're changed, tend to be a wider feather. So if you have both narrow feathers and wider feathers, you can see the shape of the feather can help you age the bird and tell you whether it's a juvenile feather, and it would be in this first cycle, or if it's a fatter feather, it would be in a further cycle. The thing with the feather is that it only grows in once in that narrow tapered shape. Any other time it grows in, it will grow in the fat wide shape. So you have to be very careful if you're using feathers that are fat and wide. They're less helpful. Narrow and pointy can point you in a direction, but fat and wide would not. So for example, this little guy here, if he had an accident, and sometimes they do, and he lost his tail, it's a mechanism to save them from predators, but if he lost his tail, he could grow in his feathers the following week and they would look adult. Okay, so tails definitely are helpful. Narrow and tapered and versus broad and truncate is very, very helpful when you're aging. I just decided to focus in my 1 hour today on wings.
Great answer.
So we do have a wing fixation.
All right, so this question, and I'm going to expand on it a little bit from the person that asked from Facebook. So theirs was more of an observation, is their understanding is that juvenile is an age class typically used by maybe bird watchers, birders more than banders who will, use terminology that we're aging with. And juvenile is a plumage. And then maybe would you add local bird and how we use local bird within the maps system to that as well?
Okay, so terminology is always in flux. And this piece of this image that we're showing right now, the word juvenile is in here, but now we've changed it to juvenile. So I need to update my picture here. So currently the term that we use is juvenile, and you'll see that any papers that are coming out now, they will use juvenile instead of juvenile. And if you're looking at this book, it'll all be juvenile, but when the rewrite comes out, it'll all be juvenile. And it's just a evolution of the terminology as things come and go. But juvenile is the new it's the new thing. Now you guys are all on the is the new way of speaking of things. Now a juvenile bird is there's birds in juvenile plumage, and that would be the bird that's here that's all red, that has only a single generation of feathers. They're all came in the nest. So that's what we would call a bird in juvenile plumage. Juvenile, though, just as a general, we could consider these guys here. So you want to be specific about whether you're talking about a juvenile bird or a juvenile plumage. Okay, and then specifically a local bird is the birds that have just come out of the nest. Those guys usually don't have all of their flight feathers grown in. They might be mostly grown in, like their wings might be almost in there. Oftentimes their tails are not all the way in, but like I said, that nest is really a dangerous place. So they're trying to get out of there as soon as they can. And so they may not wait till their wings are fully grown. And at that point in time, they're kind of clumsy. They can't fly worth a darn. And we know that if we catch a bird and we let it go and it can't fly worth a darn because his flight feathers aren't growing in and he hasn't got the coordination or the muscle mass yet, and they tend to kind of do this crazy flump. They'll fly 100 yards or so maybe, but not very gracefully, and they tend to land a little clumsily. For that week in time, and it's very short period of time, that's what we would call a local bird, a bird that we know comes from that local area. So it tells us something very specific about the time. If you are banding nestlings, those birds are also called local birds because you know they came from the local area. They haven't even left yet, haven't even left the nest.
Wonderful. Okay. So I think you answered a couple follow-ups that there were on Facebook to that as well, especially as it pertains to banding. Bird watchers oftentimes use very different terminology, so this is only as it works with banding. Okay, so let's see. So this question was, I think, specifically when you were going over Joe Bird. So I'll ask it now since Joe Bird is up. When you were talking about Joe Bird molting, all of its feathers in its second year, that is where it goes from the red, green to blue, correct?
Yes.
Okay, so whoever asked that question, there you go. So Joe Bird is molting all feathers in that scenario.
Yeah, and then not all at once, in a specific sequence and things like that, because like I said, it needs to fly.
Correct, and so this ties into that then. When the season arrives, what triggers the beginning of molt? Is it environmental factors? Is it hormonal? What triggers it?
So there's actually quite a few triggers depending on the life cycle of the bird. Sometimes it's a light cycle. So sometimes they're triggered by the light darkness proportion that will sometimes trigger things. Sometimes it's the food based, whatever, when some things show up, that's what will trigger that. And usually whatever the trigger is, will start the hormone. So there's definitely a hormonal basis that needs to be triggered by either light or food. And sometimes it is based on their life cycle. So on their breeding ability. So oftentimes if you have a nest that fails, and the bird doesn't have time to re-nest, those adults will molt right then. So it's not even a light dark trigger or food thing. They just know that, this season our nest failed. We don't have time to make another one. So that that set of hormones, the lack of hormones that are keeping them breeding, will just set off the fact that they're going to molt right then. So when you get birds that are molting much earlier than you expect, it's usually because they've had a failed nest.
Okay. So this question, whoever asked this, I'm going to change your wording just a little bit, so forgive me. But since molt is so energy intensive, are there birds that molt also during their migration, which is also energy intensive, and then they observe that they've seen that from time to time? And for the birds that do it, how do they partition that energy then?
So it's quite rare for birds to be, they might molt lightly, but they tend not to molt heavily when they're migrating. It's really when you start losing feathers from your wing foil, from your flight feathers, it makes it really hard and very inefficient to molt and migrate at the same time. Usually what happens is a bird will breed in a certain area, migrate a short distance, and go to what are called molting grounds, which are pretty new in the knowledge that we have, that there are these molting grounds, and then these birds will molt a lot of feathers very, very quickly because the resources are high. So we're thinking about places like Arizona. So a bird might breed in like places like BC or Washington or Oregon or even California and fly to Arizona in about July. And Arizona has the monsoons and a huge rush of resources and insects that come. They'll molt very quickly, and then they'll continue on further with their migration. So we used to think that they were molting on migration, but really they're using a stopover site for that. Now, I don't know who asked the question, so I can't ask specifics, but I'm wondering if when you saw a bird molting on migration, was it just a few feathers that it was just finishing off before it left on migration? Or similarly, did it just get to where it was going and start things? So there's a couple questions I don't have any clarification on, but that tends to be how it works.
Well, and obviously you're talking specifically about passerines because we know larger birds, raptors, seabirds, use an entirely different molt strategy that would reflect differently. And I believe that was actually from one of our international friends. So in an international species, an old world species, you might have a whole different ball game.
Right.
Okay, so, and this is a great follow-up. This might be from the same person too, but in the absence of good feeding potential at a site, especially for migratory birds, what's the strategy used? Is it a lower quality molted flight feather, or do they arrest or suspend a molt?
So usually molt is pretty hardwired. If you have a strategy that your species does, it's really hard for you to, for the birds to change that. Now, when you have birds that are using resources on the wintering grounds, we know, and if they're molting on the wintering grounds, because some species molt on the summer grounds and some molt on the winter grounds. On the winter grounds, we have often seen through time that as resources change throughout the landscape, the birds will follow those resources. So that's one way of dealing with a low resource availability when you are trying to molt. You have a little bit more flexibility if you don't have to get in a breeding before winter comes. But if you are trying to molt and you don't have the resources, you will just probably end up with poor quality feathers that year. And sometimes you will see birds like that. You will see birds that look like they have been through heck and back, and it's probably was because when they were molting, they didn't have the proper resources.
Okay, so let's see here. I've got one from Facebook. Do tertial feathers and greater covert feathers molt more frequently since they're more exposed to sun and degrade faster?
Yes. Someone gets a gold star. Great concept. Yes, they do. They absolutely 100% do because they are so exposed. Well done.
All right, I'm going to put they get a gold star. I'm going to type that into Facebook.
I think you should because that's great.
Gold star. Okay, and then there was some discussion on molt limits. Would you go to a photo that has an obvious molt limit, and they said they can see where the limit is, but what does it mean as far as what has happened during feather growth? Explain it one more time.
I'm going to see if I can find, I'm going to go to here because it's got lots of things happening. So, so you can see here that these are juvenile feathers. They're a little bit more brownish. These are black, but they are not as black as what's happened here. Okay, so we have cool stuff happening here. So when this bird was in the nest, it grew in its full set of feathers. and they were not the best quality. And through time, what has happened is the sun has faded them and they have turned a little bit brownish. Okay. When these first came in, they would not have been this brown. They would have been a darker color. So they do come in a little more vibrant and they fade to this brown, and they fade quite quickly. So this bird, anywhere that these are brown feathers, okay, these are left over from when it was in the nest. Then when it was a teenager and went through its first molt in the first fall, it did not have a huge budget for energy, and they're not really good at feeding. So, you know, they have to save money where they can or save energy where they can. So it molted its entire body. I should have been more specific about that. They always molt their bodies. Okay, so it molted its whole body, and then it molted all of these greater coverts. And this is our carpal covert right here, if you're looking for it. This is a nice picture of a carpal covert. So it molted these, it molted all of these feathers. And so then it molted those, it migrated, it spent its time in the winter, and before it came back, it's like, oh, I gotta look better for breeding. So, and also probably had some wear on those feathers. It molted right here. It molted these feathers during its pre-alternate, and it molted its body again. So we have birds from the nest, feathers from the nest, feathers from the first fall, and feathers from the winter ground. And these body feathers also came in the winter ground. This bird is in its alternate plumage.
So a limit is, it can be intra-tract and inter-tract. And then it's not necessarily from different cycles, but from different molts creating what we see.
Right on. Zach, you got a gold star too.
Okay, so let's see here. We're gonna do, I think probably just one or two more questions since it's 7:30. But if you have more questions, feel free to send them in to WBBA. All of our emails are up there, but you send them to Danny, send them to Holly, and we'll try to answer as many as we can that way. And if you want to ask questions when I send out the webinar link, do it there too. So let me find one or two more questions here to grab. Okay. Oh, here's maybe a tougher one.
Okay.
In the absence of established guides, how should one start from scratch when trying to learn how to ID pre-juvenile molt versus pre-formative molt, etc.? As in, when working with rare species with few or no reliable molt records, how do you do that?
Okay, so the first thing that you should do is you should read up on what is happening with that group in known species. So if you're looking at warblers, an unknown warbler, I would read up what I can about other warblers. So start with what is known, because the patterns within a group tend to be pretty rigid. So the thrushes tend to do one thing, the chickadees, the parrots tend to do one thing, the warblers tend to do one thing. So start with that knowledge, which is already a good base. And then if possible, track the birds throughout the year. So if you have an opportunity to, if you're banding, it's great because you can band at different times of year, catch birds at different points in their life cycle, and take pictures. We have cameras that can take such great pictures right now. So take lots and lots of pictures. Now, the same concepts will apply across all passerines, where the juvenile feathers are going to be of less good quality. They're going to fade more as time goes on. And so you'll be able to see the differences between the groups. Molt is tricky when you don't have a whole year of time with them. So just seeing as many birds as you can and taking as many pictures. Now, there are great people out there who know lots and lots of molt and are always developing new systems. We're talking like WRP guys, Wolf, Ryder, and Pyle. Those guys are always learning more, and they're a bit of molt junkies. So, you know, if you send them pictures and ask for their help, those guys are the real experts on things, and they would love to jump in and help with you if you're trying to learn new species.
Okay, I'm gonna do, I think, two more. I'm gonna sneak in two more here. First, you mentioned that the current the aging system that you're using in this talk, it does not work for birds in the tropics, whereas WRP does. Could you explain why the current system does not?
So the calendar system of aging does not. Biologically and molt-wise and plumage-wise, the system is perfect. Applying ages, it's a different way of aging the birds or calling the age of the birds. So when we have a bird here, we have a specific breeding season, and in North America, in the temperate zone, breeding tends to happen during the summertime we get birds that are hatched then. When you turn the calendar, they turn a certain year. That works great. When you go to the tropics, you can have birds that hatch, let's say they hatch on December 15th. Okay, those birds are in juvenile plumage. They're a hatchier bird. That's great. Then you get the nest that's, you know, half a mile down the road, and it hatches on January 2nd. Okay, so those birds are hatchiers on January 2nd. Let's go back to that first nest. It hatched on December 15th. Well, if we use the current calendar system, as soon as you flip the calendar on January 1st, those December 15th birds become second-year birds because they're in the second calendar year of life. But really and truly, they're the same cohort as the ones that were hatched on January 2nd or January 3rd. That's the same group of birds. They're both young birds. They're both not able to breed. They both are juvenile plumage. So the system of flipping calendars doesn't work when you breed over the calendar flip. You want to talk about the biology and what plumage they're in, because they're all in juvenile plumage. They're all going to mature and be able to breed at about the same time, you know, a certain amount of time down the road. So that's why the WRP system is a better way for when you're talking about homologies among species. Okay,
I'm going to do one more question, everyone. Let me grab one here. There's a lot of requests for additional webinars on neotropical species, a lot of requests for WPR, maybe a request for a webinar on molt strategies, you know, in a very general sense. Let's see, there was some great discussion on the physiological processes as it ties into molt. So if you want to go back in the chat box, everyone, you can see that on your own. The chat will also be available when I send out the link to the recording, so you'll be able to go back and read the chat as well, because there's a lot of great answers in here. You know, actually, I think that's going to do it for questions. I feel like we've answered a lot of these, and I think a lot of these will be maybe better answered in a future webinar.
Awesome. Well, this was lots of fun. I'm really glad that we could be there and share this molt stuff, and I hopefully you've got your interest peaked and that you guys are going to do some more exploring on molt and birds and possibly into bird banding.
All right. Well, thank you so much, Dani. Thank you, Holly. Thank you, everyone, for joining us. If you registered, keep an eye out for that link. You can still register. If you saw that link somewhere, share it with someone else. And anyone who registers, I will make sure they get the email that contains the recording, the chat transcript, everything that goes along with it. And I will try to include some of the pieces that Dani had, the Joe Bird. I'll try to get a link to the Joe Bird or an actual PDF, and then I will include the PDFs from IBP that also kind of take Joe Bird and how Joe Bird would be, you know, how Joe Bird would exist within a WRP system. So I will make sure to share all of that with all of you. Thank you all so much. Thank you, Dani. Thank you, Holly. Have a great night, everyone.
Thank you. All right. Thanks, Zach. Appreciate it.
And make sure to like WBBA on Facebook. Go to our website. Check us